So we are going to be reviewing systems of equations today. Okay, systems of equations. So when we identify that we have a system of equations that we will be solving, they're represented with this brace and then y and then two equations. So I have y equals 6x minus 11, and I have negative 2x minus 3y equals negative 7. So this brace out in front shows that this is a system of equations. Okay, we use systems of equations when we are kind of comparing two things and we're trying to figure out like which one's the better purchase, different combinations of goods, things like that. So that's what we use systems for. When we have a system, we are solving for the solution. So solution of a system, that is the point where the two linear equations intersect. Where the two linear equations intersect. So if I have two lines on a graph that are intersecting, that means that they are crossing at one point, which means that my solution needs to be represented as an ordered pair. So the solution to any system is going to be represented as an ordered pair, which looks like this. Questions so far, anybody? We're feeling okay? So I'm going to go ahead and do example one. Example one is going to be a graphing example. Now, here are the things I want to remind you. We never graph on binder paper. The only reason I'm graphing on binder paper is because it's my notes. Okay, we're not going to graph and turn stuff in on binder paper. That's not okay. So I'm going to draw this graph over here. I'm going to make some tick marks really quickly. Something that looks like that. Now, in the beginning of the year, we've worked a lot with graphing lines that are linear. So working with slope-intercept form. These are both written in slope-intercept form. So this should be review as far as how does graphing go. So for my first equation, negative 3 is going to be my y-intercept. So 1, 2, 3, plot the point. The slope here is 1, so I go up 1 over 1, up 1 over 1, up 1 over 1. It's kind of enough points for me to figure out what my line should look like. I get out my straight edge, draw my line. Remember, I saw a lot of homework recently where my line, well, not my line, people's lines didn't have arrows at the ends. Y'all need to put an arrow at the end. Okay, that's really important. It also needs to be drawn with a straight edge, really important. Last thing that is really important is that my line is extending past my points. Does everyone see how the line is long and extended past? If I do a short little line that only touches the points, that's not going to help me when trying to solve this system by graphing. So my next line is this one here. There is no y-intercept, so my point is starting at the origin. My slope is 2, so I go up 2 over 1, up 2 over 1. Now, I can start to see the shape of this line, and you can see that it's going in the opposite direction up here, which means it's probably not going to intersect. So I'm going to now plot some points down in order to try to get closer to the line I've already drawn. So I'm going down 2 over 1, down 2 over 1, down 2 over 1, something that looks like this maybe. This is why we don't graph on binder paper, because it doesn't look very good. This line is looking very janky. I'm going to try my best here, but this is not pretty at all. So I think it's supposed to be intersecting right around here. Again, this is why we're not graphing on binder paper, y'all. So this is a great lesson in why you need to use graph paper. So this appears to be 1, 2, 3, like -3, and then 1, 2, 3, 4, 5, 6, -3, -6, I believe is the solution here. Now, again, because this is a janky graph, what I'm going to do is I'm going to check that that solution holds true, because I don't have a very clear intersection at this point. If I used actual graph paper, I would have a very clear intersection, just so we're all understanding that. So here I have y equals x minus 3. Substitute -6 for y equals -3 minus 3. -6 is equal to -3 minus 3, which is -3 plus -3, so -6. Yep, that one holds true. And then I have y equals 2x. My y, substitute -6, equals 2 times -3. That makes -6 is equal to -6. Yes, holds true. So this is in fact the solution to this system. Okay, so that's graphing, which that should feel very review-like. Now what we're going to do is we're going to get into solving these systems algebraically. So here is example 2. So before we start example 2, here are the steps that we're going to follow. Step number 1, we are going to set one equation equal to a variable. Okay, I didn't say which variable. I just said it needs to be equal to a variable. Number 2, I'm going to substitute into equation number 2, meaning whichever equation I didn't change in step 1, I'm going to substitute into. Number 3, I'm going to solve. Number 4, I'm going to now substitute and solve for the other variable. So those are kind of the steps that we're going to go through the process for solving a system. So here's my system. I have y equals 3x plus 8, and I have 8x plus 4y equals 12. So if step 1 is to set one of my equations equal to a variable, that would mean that I have an isolated variable on one side. Well, my first equation listed here already has that, so I don't actually need to do that. So now what I'm going to do is I'm going to take my other equation, which was 8x plus 4y equals 12. And this up here says y is the same as 3x plus 8. So what I'm going to do is I'm going to substitute, instead of having y, I'm going to put 3x plus 8 is equal to 12. Now it says for me to solve, so of course I'm going to start by simplifying, distributing that 4. So I have 8x plus 12x plus 32 equals 12. Combine like terms, 20x plus 32 equals 12. Minus 32 minus 32. This is now 20x equals negative 20. Divide by 20, divide by 20. X equals negative 1. So I have now solved for one of my variables. I need to go back and I need to solve for my second variable, which would be y. So I'm going to pick one of the equations from the beginning. I'm just going to go ahead and use y equals 3x plus 8. I'm going to substitute my x value in so I can figure out what y is equal to. So I have y equals 3 times negative 1 plus 8. I have y is equal to negative 3 plus 8. Y is equal to 5. So I now have an x value and a y value. I'm going to write this as an ordered pair. So negative 1 comma 5. Here is my solution. And then like anything, when we solve equations, I'm going to now do a check to ensure that this solution holds true. So I'm going to take one of the equations. I'm going to take the second equation here, which was 8x plus 4y equals 12. And I'm going to substitute this back in to see if it holds true. So I have 8 times negative 1 plus 4 times 5 equals 12. This makes negative 8 plus 20 equal to 12, and that's 12 equal to 12. So yes, my solution holds true. I solved that system correctly. So that is solving it algebraically. Now, this one, we happen to have one of my equations set equal to a variable to start. So now we're going to look at another example where that's not the case. So this is example 3. So example 3 is negative 4x plus y equals 6 and negative 5x minus y equals 21. So neither one of these is set equal to a variable, so I need to start by converting one of them. I'm going to just choose the first one. So I have negative 4x plus y equals 6. I'm going to add 4x to both sides. That leaves me with y is equal to 4x plus 6. So here is the rewritten equation, the converted equation that I'm going to use, because I've now set it equal to y. I'm going to take my second equation, negative 5x, that is not an x. Sorry, everyone. Geez Louise. Negative 5x minus y equals 21. I'm going to now substitute for y. So I have negative 5x minus 4x plus 6 equals 21. Next, I'm going to distribute the negative into my parentheses. So I have negative 5x minus 4x minus 6 equals 21. Combine like terms, negative 9x minus 6 equals 21. Move the 6, negative 9x equals 27. Divide by negative 9, divide by negative 9, x equals negative 3. Okay, so I have now solved for x. I need to take that, substitute it back in, and find out what my y is. So here I have negative 4x plus y equals 6. -4, substitute -3 plus y equals 6. That means that this is 12 plus y equals 6. -12 minus 12, y equals -6. So my solution is -3, -6. And then, of course, I'm going to do a check. So I'm going to take one of the equations. I'm going to use -5x minus y equals 21. I have -5 times -3 minus -6 equals 21. That makes 15 minus -6 makes +6 equals 21. And 21 is equal to 21. So, yep, my math worked out. Okay, so that is solving systems of equations.